ಆತ್ಮೀಯ ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರೇ, ವಿದ್ಯಾರ್ಥಿಗಳ ಜೀವನದಲ್ಲಿ ವೃತ್ತಿಪರ ಶಿಕ್ಷಣ ಅತಿ ಮಹತ್ವದ ಘಟ್ಟ. ಈ ಘಟ್ಟವನ್ನು ತಲುಪುವ ಉದ್ದೇಶದಿಂದಾಗಿ ತಮಗೆ ವೃತ್ತಿಪರ ಶಿಕ್ಷಣಕ್ಕೆ ಸಂಬಂಧಪಟ್ಟ ಸ್ಪರ್ಧಾತ್ಮಕ ಪರೀಕ್ಷೆಗೆ ಮಾರ್ಗದರ್ಶನ ಅತ್ಯವಶ್ಯ. ಆ ಮಾರ್ಗದರ್ಶನ ನೀಡಲು ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್ಸ್ಗೆ ಸಂಬಂಧಪಟ್ಟ ಹಾಗೆ ಕೆಲವೊಂದು ಮಹತ್ವದ ಪ್ರಶ್ನೆಗಳನ್ನು ಚರ್ಚೆ ಮಾಡಲು ನಿಮ್ಮ ಮುಂದೆ ಬಂದಿದ್ದೇನೆ. ಈ ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್ಸ್ಗೆ ಬರಲಿರುವ CET ಪರೀಕ್ಷೆಯಲ್ಲಿ ಕನಿಷ್ಠ 3 ಪ್ರಶ್ನೆಗಳು ಪ್ರಶ್ನೆ ಪತ್ರಿಕೆಯಲ್ಲಿ ಇರ್ತವೆ. ಈ ಹಿಂದಿನ ಪ್ರಶ್ನೆ ಪತ್ರಿಕೆಗಳಿಗೆ ಹೋಲಿಕೆ ಮಾಡಿದಾಗ ಪ್ರತಿ ವರ್ಷವೂ 2ರಿಂದ 3 ಪ್ರಶ್ನೆಗಳು ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್ಸ್ನಿಂದ ಬರ್ತಾ ಇದ್ದಾವೆ. ಆ ಪ್ರಶ್ನೆಗಳಿಗೆ ಸಂಬಂಧಪಟ್ಟ ಹಾಗೆ ಕೆಲವೊಂದು ಚರ್ಚೆಯನ್ನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಮೊದಲನೆಯ ಪ್ರಶ್ನೆ, ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್ಸ್ನಲ್ಲಿ ಇನ್ ದಿ ಕಾಂಪ್ಲೆಕ್ಸ್ ಫಾರ್ಮೇಷನ್ central metal atom or ion acts as. For this question, we have 4 options here. Option A, Lewis base. Option B, Bronsted base. Option C, Lewis acid. Option D, Bronsted acid. We had the Bronsted-Lowry concept of acids and bases and Lewis concept of acids and bases. According to Lewis concept, an acid is a substance which accepts a pair of electrons. Base is a substance which donates a pair of electrons. In the complex formation, central metal ion accepts electron pair. Ligand donates electron pair. So therefore, in the complex formation, central metal atom or ion acts as Lewis acid. So for this question, the correct option is option C, Lewis acid. ಈಗ ಎರಡನೇ ಪ್ರಶ್ನೆ, the groups satisfying secondary valencies of a cation in a complex are called. Option A, ligands. Option B, radicals. Option C, primary valencies. Option D, anions. We know that in a complex, we have central metal ion which is a cation, the ligands which are satisfying secondary valencies. So therefore, the correct option for this question is ligands. The groups satisfying secondary valencies of a cation or central metal ion in a complex are called ligands. The number of ions formed on dissolving 1 mole of ferrous ammonium sulfate FeSO4 NH4 twice SO4 6H2O in water is option A 4, option B 5, option C 3, option D 6. We know that ferrous ammonium sulfate or Morse salt is a double salt. When a double salt is dissolved in water, it dissociates into its constituent ions. If this Morse salt is dissolved in water, it dissociates into Fe plus 2, SO4 minus 2, 2NH4 plus and SO4 minus 2. The water component of this does not undergo ionization. Now you can count the number of ions formed here. 1, 2, 4, 5. So therefore, when Morse salt is dissolved in water, the number of ions formed is 5. So the correct option is option B, 5 ions. next question is the number of unidentate ligands in the complex is called option A, effective atomic number, option B, coordination number, option C, primary valency, option D, oxidation number. The answer for this question goes according to the definition of the coordination number. As per the definition, coordination number is the number of unidentate ligands or the donor atoms linked to the central metal ion. Since the number of unidentate ligands in the complex has been asked here, that number of unidentate ligands represents coordination number. So therefore, the correct option for this question is option B, coordination number. The oxidation state of chromium in the complex CrNH3 4 times Cl2 plus is, options are A plus 3, plus 2, plus 1, 0. Out of the 4 options, now we have to search for the correct option. For this, the concept behind this is the sum of the oxidation numbers of all the constituents in the coordination sphere is equated to the charge on the complex ion. When the oxidation number of the central metal ion is not known, we can take this oxidation number as X. And these are the ligands. The sum of the oxidation numbers of all these constituents of the coordination sphere is equated to the charge on this complex ion to get the oxidation number of this central metal ion. To get this, let us solve this. Chromium oxidation number is unknown. It is X. Ammonia, it's a neutral ligand. Charge on this is 0. So therefore, X plus 4 into 0 plus chloride ion is a negative ligand. Charge on each chloride ion is -1. There are 2 chloride ions here. 2 into -1. This is the sum of oxidation numbers of all the constituents of coordination sphere. This sum is equated to charge on the complex ion, that is +1. When we do this, we get the value of X here. X is equal to, this is -2. This -2 is taken on the other side to get the value of X. So +1 +2, this is +3. So X is the oxidation number of chromium in this complex ion. So therefore, we go for correct option here. Correct option is A, +3. This is the answer for this question. So in the previous questions, we had the questions related to calculation of coordination number and also the oxidation number. So now we'll move to a question which is a combination of these two. The concept of coordination number and also the oxidation number is included in this question. The question goes like this: which response gives the correct coordination number and oxidation number of the transition metal atom in the complex CONH3 twice, H2O twice, Cl2 plus? The options are coordination number 2, oxidation number +3, coordination number 3, oxidation number +1, coordination number 4, oxidation number +2, coordination number 6, oxidation number +3. In the previous question, we had seen that the number of donor atoms linked to the central metal ion is coordination number. In this complex, there are two donor atoms linking to this. There are two donor atoms linking from this. Again, there are two donor atoms linking to this. Totally, there are 6 donor atoms linked to the central metal ion. Therefore, coordination number here is 6. Even based on this, we get a correct option here. Amongst all the coordination numbers given here, only option D has the coordination number 6. Therefore, this option appears to be correct option. Though it appears to be correct option, we have to verify this by taking this oxidation number also. The oxidation number is calculated as I had explained in the previous question. Here, cobalt oxidation number is assumed as X. Plus, ammonia is a neutral ligand. Charge on this is 0. Plus, water is also a neutral ligand. The charge on this is 0. Plus, chloride ion is a negative ligand. There are 2 chloride ions. Charge on each chloride ion is -1. This sum is equated to charge on that complex ion. The sum is X plus 2. This is 0, this is 0. I'm sorry. X plus -2 is equal to plus 1. Therefore, X is equal to plus 3. So, this option, which was correct in accordance with coordination number, is further confirmed by oxidation number, that is plus 3. So, oxidation number and coordination number of cobalt in this complex ion is plus 3 and 6. So, therefore, the correct option is D. Which one of the following is a monodentate ligand? Cn minus ethylene diamine tetraacetate ion EDTA, oxalate ion C2O4 minus 2, ethylene diamine NH2 CH2 CH2 NH2. We know that ligands are classified into monodentate, bidentate, tridentate, tetradentate, polydentate, etc. Here, Cn minus is a monodentate ligand. EDTA is a polydentate ligand. Oxalate ion and ethylene diamine are bidentate ligands. Immediately based on this, we get the correct option for this question. The monodentate ligand amongst the given 4 ligands is Cn minus. So, the correct option for this is Cn minus. It is a monodentate ligand. EDTA is a hexadentate ligand. There are 6 donor atoms in this. While oxalate ion has 2 donor atoms, it can link through 2 oxygen atoms. So, it is a bidentate ligand. In ethylene diamine, there are 2 donor sites here. 2 nitrogen atoms are the donor sites here. This is bidentate ligand. This is also bidentate ligand. This is hexadentate ligand. So, monodentate ligand is Cn minus. So, the correct option is A.